So we can go down to centimeters level, like 10 centimeter level. That's what we do in sport when we really try to push the technology, our technology, to the very maximum. We can get a fraction of a feet accuracy with like 100 milliseconds delay. And off the shelf, it also means that we have been taken in the past devices that already existed and just turn them with a 3 to 5 line of firmware, so software code, into a Quuppa trackable device. So we can only use one device in order to be able to pinpoint where you are.
You're listening to The Hitchhiker's Guide to the Ecosystem with Steve Statler.
Welcome to The Hitchhiker's Guide to the Ecosystem. My name is Steve Statler of Statler Consulting, and this podcast is aimed at location-aware solution designers, and it's a continuation of the work we did on this book, The Hitchhiker's Guide to the Ecosystem, giving it some extra shelf life. One of the more interesting companies that we covered, well, actually they were all interesting, but a particularly interesting company we covered in the book was Quuppa. And I am really pleased we've got Fabio Belloni, who is the co-founder and chief customer officer of Quuppa, who has just moved to the United States. So Fabio, welcome to the show and welcome to America.
Thank you. Thank you so much. Glad to be here.
Yeah, it's exciting. And you've actually always been this kind of, your company that you founded has always been this very interesting company because you take Bluetooth where it's never been before in terms of the level of very high precision and accuracy. And that's very interesting because I think it portends the direction that the industry is going. So we want to hear about the company, the product, what it can do, and why you're expanding to the US now. A little bit about how the technology works and the market, where it's being used, and your view on it. So let's get stuck in and just tell me a little bit about what your company does.
Right. So Quuppa is a technology provider. What we do is provide an accurate dot, the famous dot on the map. So as a technology provider, we have always been fascinating into creating a technology that could track and monitor and following object or people or any kind of things that an end customer or an integrator might be interested to monitor. Because it's becoming quite clear from the market that knowing what is where and eventually also knowing what is happening over there in terms of remote sensing and sensing data in a remote location is actually a very strong enabler for be able to unbound and untackle a lot of different services. And location-based services is all about be able to practically combine actionable information into the location and the tracking data and being able to create alarm, alert, or location-based information, or to provide effectively any kind of insight of how things and people are moving in the environment and also in the relationship with each other.
So we talked about accuracy. Just how accurate can you get to?
So we can go down to centimeters level, like 10 centimeter level. That's what we do in sport when we really try to push the technology, our technology, to the very maximum. We can get a fraction of a feet accuracy with like 100 milliseconds delay. But is that always needed? Well, our answer is, to be honest, no. There are certain environments where effectively the sub-meter accuracy it's more than enough for getting to understand where people are or where objects are placed. What is very important when talking about accuracy, it's the combination, of course, with also delay, because there is a lot of location-based services which are relating, for instance, to security and safety and alarms, where you got to be able to take decision within a fraction of a second. And that's practically been always one of our concern is like, how can we somehow find the right trade-off and combine the accurate dot together with a low latency at the as light as possible infrastructure cost, and trying to deliver that into the end customer so that they can also leverage on using a radio technology which is not invented by us, but that is already pervasive into the market, and effectively be able to leverage on the volumes of such radio components, and possibly even to reuse some of the components that they have already built, and simply by making some small software modification, giving a new life to those devices and make it so that can become trackable.
Yeah, I think that's a really good point. So you're building on top of Bluetooth. It's not like you're using some exotic radio technology with lower volumes. This is not ultra wideband, which is, has accuracy, but the volumes just haven't been there in the underlying chipsets. You're using the radios that other people use. And just to finish off, this real-time thing, I think you guys have done a great job with your website. You have videos of foosball tables with tracking the movement on there, and also ice hockey, where these guys are moving at huge speed. And so that, I think, captures people's imagination. How do you do it? And well, let's talk about, before we get to the science of it, and we don't need to go into too much detail, but just at a practical level, what's required? I've decided I want to track my staff, and I really want that high precision accuracy. And I've got a warehouse that is 20,000 square meters or whatever. What's required?
Yeah, so if someone would decide to start adopting the Quuppa system, the first thing you have to install are the enablers, the locators, which are somehow the lights that illuminate your space. So this is a locator. It's a round device. It weighs about 500 grams, and it's very easily mounted and attached. You can mount it flat, you can mount it tilted on the ceiling, and effectively the locator works like a radio camera. So what it does, it can see in the space where the signal, the Bluetooth low energy signal, comes from. And by knowing where the devices are placed into the indoor environment, and we have tools and software application for doing that, every device can track in real time the direction from which the signal comes from, and by knowing that, effectively retrieve the position of where the object is moving. So really the intuition is like having not a video camera, but a radio camera. So something that can follow as the object moves around. So we started to work on this technology in 2004, 2005. So whatever you see as Quuppa technology is something that has been created through several years of hard work. And everything has now been packaged in the way that we really want to make the solution scalable, which is another critical component for being able to tackle the market. So if someone wants to get the system in place, once they have placed the locator on the ceiling, then the next thing is to decide what do they want to track. So if you have, for instance, pallets, or you have a forklift, or you have a person, so you can give either a tag. So this is a Quuppa tag.
Okay.
So this is a reference design tag, which is used in the market by several of our customers. Yep. And this is a device that contains a 3-axis accelerometer. He has a button, he has a temperature sensor, and it has an easy fix and mount. But we are cautious of the fact that every industry, every customer has different needs on how this tag needs to be. And that's why at Quuppa we have consciously decided to open up fully the whole interface of how to build tags. So Quuppa provides for free a documentation that describes on how the tag is built and how the tag should transmit. Clearly, this is again not any kind of dedicated device. Everything that is inside this device is off the shelf.
Okay.
And off the shelf, it also means that we have been taken in the past devices that already existed and just turn them with a 3 to 5 line of firmware, so software code, into a Quuppa trackable device.
So we'll talk about the receivers in just a second, but the beacons themselves, what's different about that beacon from any other beacon that I could buy from a Contact.io or Estimate?
So from the radio perspective, they are actually the same. So they have inside the Bluetooth Low Energy radio. Mm-hmm. They are broadcasting on BLE advertisement packet. Mm-hmm. The difference is the content in the payload. Mm-hmm. So practically, if you want your beacon or your device to be Quuppa trackable, you simply need to add into the payload of the Bluetooth Low Energy advertisement packet a certain known sequence. And once you give the right structure to your advertisement packet, then suddenly your object illuminates, and our locators can start to track it.
Why do I need a known sequence? I mean, beacons are uniquely identified anyway through, or potentially at least, by the UUID major minor device number, the MAC address.
That's correct. But we go a step beyond that. So if you are using practically the major, the minor, and all the information in the standard, effectively we are doing the pure beaconing. So you send a radio packet, and on the other hand, you receive it, and then based on power information, you can try to retrieve within which proximity you are to the receiver device. But in here, we go a step beyond. We actually want to do the AOA, angle of arrival estimation. Mm-hmm. So effectively, the training sequence that is inside the BLE radio packet allows the locator to compute the spatial direction, the direction in space from which the signal is coming from, together with identify uniquely which transmitting device is which, and keeping on following it. So the idea is really the same as if your locator is on the ceiling would be your hand, and in your hand you will have a laser pointer. Mm-hmm. So the laser beam is a direction in space, which is identified by 2 angles, azimuth and elevation. And when you project the laser beam to the floor, well, you see a dot, mm-hmm. and the dot is 2D positioning.
Right.
So Quuppa practically, and that's also another distinctive feature of Quuppa with respect to other technology like ultra-wideband. Since we are not measuring distances, we don't need to trilaterate in order to be able to retrieve the coordinate of an object. So we can only use one device in order to be able to pinpoint where you are. And this opens the door on 2 different, very interesting use cases. For instance, in security and safety, if you want to do access control, and if you want to, control a door, for instance, how you open or close a door, or simply measure traffic through a gate, you effectively just need to put one locator on top of the area, and then the locator will make sure that it will track everything that would move within his area of reach. And if you go to very complex industrial environment where there is a lot of metal and a lot of known idealities, you don't need to all the time rely on having at least 3 nodes looking at you in order to know where you are. But even if you will lose connection and to some of the devices, it's just enough that one of them sees you, and that's what is gonna position you. So effectively is a solution which is extremely robust to be used even in a heavy and a harsh environment.
Why would I go from 1 unit to 2 units? What do I get if I have 2 receivers that I didn't get with 1? Because it sounds like you can do a lot of things just with 1.
Yeah, I mean, having more units and more devices on the ceiling, it builds redundancy into the system. So it practically builds on the reliability of your dots or some extra robustness into the system. Okay. So the idea is like, the same as GPS. You could get your position only with 4 satellites, but then if you have more, then your position practically becomes more stable and reliable. And it's the same thing, because remember that we are always battling against delay. I mean, we could always, provide more accuracy simply by increasing the filtering and having a longer delay. But we don't really want to do that, because then you're closing the door to all of those truly real-time use cases. So what we decided to do was to not make an hard decision from our customer, but to give them the chance to choose. They can still increase the delay if they want to keep down on the infrastructure part, or if they want to have more real time, they just need to put a little bit more infrastructure. And they can decide for themselves, depending on their use case and the end customer needs, what is the right balance. And it can also be that they don't want to cover, for instance, one area continuously with sub-meter accuracy, but they could do this kind of sparse deployment, where in front of doors or places in the indoor space where they really want to have an high accuracy, they put the locator. Everywhere else, they can just have locator like 30 meters apart, even 50 meters apart, and that could give enough information on which part of the building you are, and everything in between, right? Okay. We don't dictate what the customer can do. We just want to give them the enablers for them to do it.
So what density do I need if I want 1 meter accuracy, for example?
So typically the distance between the locators is 2 to 4 times the ceiling height. That's like the rule of thumb.
Okay.
So if you have a ceiling height of, let's say, 3 meters, if you are in an environment which is what we call confined. Confined means something that would have thick walls or a lot of metals, and really a lot of obstructions around. Therefore, we would suggest you to put locators every 6 meters. So that would be 3 meters high, twice the ceiling height. If you go into environments that are more open, what we call semi-confined, therefore you can start to stretch the distance between the locators, and you can go at 3 times the ceiling height.
So this is fascinating, because this is like the opposite of solutions, which is the bulk of the solutions use receive signal strength, and there if you've got a high ceiling, then that's really challenging, because the difference in signal strength becomes lost in the noise. But in your case, actually, high ceilings in warehouses. One of my clients is a warehouse 30 feet. High ceilings, and I'm like, oh my God, what are we gonna do? We're gonna have to suspend these receivers on wires or something. But in your case, that's actually an advantage, it sounds like.
Yeah, it is, because again, think about the camera, right?
Yeah.
If the space and the environment is more open, then your camera has a better view side, right?
Right.
Side view, and the same thing would be the locator. The higher is the ceiling, in principle, the higher is the footprint that every locator would have in terms of coverage. And we have even built 2 different kinds. So this is the LD6L locators, which is the one that we typically use for indoor spaces, or for spaces where you have a ceiling height which is less than 12 meters, and you still want to retain the sub-meter accuracy. If you instead go into an environment which are much higher, then we have another device which is rectangular in shape. You see it from the website. It's called LD7L. And that device actually it's IP65, so it's very weather resistant. Remember, we live in Finland. So even though I'm in the States now, we have a lot of deployment in a non-friendly and cold environment.
Right.
So we really had to design the device to withstand such harsh condition, and also we wanted to design them so that they will be able to measure accurately at much longer distances.
Okay. So that has greater range then? It's a more sensitive antenna, and it's...
Oh yeah, it's a significantly more sensitive antenna. Just to give an example, the communication range between this device and a tag, so these 2 devices together, it's 110 meters.
Okay.
So if I would mount this one vertical on a street, I could move 110 meters away and I can still receive the signal.
Wow.
And then if I would use the other device, 7L, I can actually move 300 meters away, which actually means that now you can go to an environment like sport. Let me give you an example. If you go to a 60, 90,000 people stadium, you can't mount the locators right next to the field where the players are performing. You got to mount somewhere very high up outside of the view of the spectators, and typically would be practically where the lights are mounted on top, and that can be easily over 100 meters away from where the game is played. So you can think of the locator like a camera, where the lens of the camera gives you the possibility to zoom in. And
so,
in fact,
can you talk about an example of that? Is there a sports stadium where you've done that?
We have. Some of those are in the U.S. Some are in Europe. I don't think we have yet something in Asia, but there might be some surprises coming quite soon. And we have a few of these stadiums that are public. Some are instead private places.
So give us an example of a public one, and just to kind of give us a rough sense of how many of those receivers, what sort of accuracy, and what do they use it for?
So if you use it in sport, it depends on the sport. So one public place that everyone is welcome to go to visit is, for instance, the University of Waterloo in Canada. And we have done the project together with one of our partners in sport, Hockey Tech. So in that case, we are using two parallel systems. So we use two systems of 10 locator each in order to be able to track both teams. And you're talking about 40 plus player, all the referees, so roughly 4 or 5 people, plus the puck. And the puck itself moves at about 40 meters per second. So, and the players is something that can move quite significantly faster than what the runner could do. So when we do hockey, for instance, tracking, we have the puck transmitting at 50 hertz. So 50 times per second, we can give 50 position per second, and the players are doing 20 hertz, 20 position per second. So what we build inside the system, because everything that I described so far, it's roughly 20% of what the Quuppa system can do. So I just described practically the position part. But in order to build a system that is truly scalable, well, you have to be able to talk with your devices. Those tags or transmitter cannot just be dummy devices. So we have built within the Quuppa infrastructure and the Quuppa system what we call the backend channel. And that one allows for a full two-way communication towards each and every one of the tag, so that we can command them, control them, monitor them directly from the web service API, which means from the cloud, which means from remote, which means that from here in my office in DC, I can actually connect to any of the sites we have in the world and be able to shut down the tag, say to the tag to transmit faster or slower, or tell to the tag to give me out a different kind of data that they might be recording. Because as we said before, the tag also has sensors. And all those sensor data, they come out in the same interface.
So the puck is kind of got an accelerometer in it, and you can find out the speed from, well, I guess you can find out the speed because you can just track the movement, but...
Exactly. There can be an accelerometer in it, and that would open the door to even more exciting things. But I mean, to be able to track the velocity and plot all of that, and we have, by the way, some example on our webpage. So.
Okay. So that's interesting. So you can turn up and down the frequency, because I was thinking, man, you're going to burn through batteries really fast. And I guess that doesn't matter in a sports environment. You can get them to change the batteries. But it sounds like you can throttle that back and turn that up. So, how much are we talking about? Is this like, how much does a beacon cost, and how much do these receivers cost?
So let me first answer about the battery consumption, because that's actually one of the key points with respect to some of the other technology, again, for scalability and cost, right?
Yeah.
So the technology, the Bluetooth Low Energy radio, has been becoming more and more efficient in terms of power consumption, and that is something that has been benefiting us. So the latest model of the Quuppa tag, which is going to be available next year, is a device that can transmit 1 packet per second continuously, 24/7, per something about 3 to 4 years continuously.
Okay.
So that means that if you would, for instance, start to shut down the tag when, for instance, your shop is closed, well, effectively your battery is going to consume just for the discharging of the battery itself,
right,
more than for the utilization. And that also means that in sport, we can actually have devices which can last an entire season. And by doing that, you are practically killing the kind of maintenance cost and making the overall operation much more effective. Because if you would have tags that need to be constantly charged, well, that means that you need to have at every single game or every single training session someone, which are typically not the players, dedicated to having the device charged, distributing the device, collecting the device, cleaning. Yeah. I mean, it's a lot of overhead, right?
Yes.
That is typically not always considered at the beginning when the system are under evaluation, but I heard some people and then complain later on about that.
Yeah, no, good points, well made, and you've definitely kind of, I think, established the value. I would actually like one of those receivers just to have it in my office because it looks cool, not because I need to track anything. But how much do they cost?
So the Quuppa tag is a device, as I said, that is a reference device. So Quuppa practically built this as an example. Yeah. The Quuppa tag starts at 25 euros each. And then the price goes down with volume to like 20, 15, and so. Okay. But I really wouldn't use this one, to be honest, as a reference on the cost, because we have already, and if you go to our webpage, we have 3 companies listed there now under the Quuppa ecosystem, and in total we have 9 companies building already their own tags. Yeah. Some example is Fujitsu. Fujitsu is one of our partner into the IoT and ecosystem work, and they have built their own tags with their own use. So in that case, we have some partners that have been able to build some of the tags, like for instance, a NISA solution that is our partner with whom we work in the hospital space and in healthcare space. They have been able to build tags that cost in the order of like $5 each.
That's pretty amazing. Okay, so the tags sounds like you're kind of on the same ballpark as the rest of the market. There's nothing like special that makes them super duper expensive. But those receivers, and we haven't actually talked about how they work. I do want to do that, but just how much? What's the kind of the ballpark range for those? Just so that people, I think people are assuming that this is like a Maserati kind of price tag. So I'm bracing myself. Thank you so much for listening to this first half of the Quuppa interview. This year's New Year resolution was we weren't going to do any interviews that lasted longer than half an hour. This one's an hour, and the second half is actually even better than the first half. So do come back, hear how much the Quuppa receivers cost. It's a lot less than a Maserati. I was amazed. We're going to be talking about how the technology works, some commentary on the future of the Bluetooth standards and angle of arrival, Quuppa's partner strategy and who they're working with, which includes some pretty surprising companies. We're going to be talking about the role of asset tracking and how Quuppa can work with location for phones, some of the limitations, and also what it was that is bringing Quuppa over to the US. So we really hope that you will join us for this. If you have been, thanks for listening. So the most challenging questions there are which 3 songs you'd take on a mission to Mars. So Have you had a chance to think about that?
3 songs to Mission to Mars. Well, I I actually I love David Bowie, so I would definitely take a couple of those. So Space Odyssey is one of my favorite ones.
Space Oddity. That's interesting. So that we actually just interviewed Colin Lowenberg from Cisco. He chose the same song. So which would be the other Bowie song because that one's taken. Sorry, we only have one digital copy.
So that one is taken. So then, well, if you travel to Mars, it's going to be a long journey.
Yeah.
So you got to have something that is going to keep you up tempo.
Yeah.
And then I will take probably something from Bruno Mars.
Oh, okay.
And so Uptown Funk or Uptown Girls. I think that's a good one.
It is a great one. Yeah.
Sing along in the space shuttle.
Yeah. And you can dance, get some of that exercise you need to keep in shape.
That's right. And then I like rock music, so I would probably take something of Metallica for the time in which I'm a little bit more energetic and I feel like to jump around. And then I like a lot classical music.
Okay.
So I typically relax quite a lot by listening to Beethoven.
Okay, so you need to give me specifics though, because what we're starting to do is actually capture the music and play it over. So which Metallica would you like?
So Metallica is probably gonna be Master of Puppets.
Okay, Master of Puppets.
And then for Beethoven is gonna be Al Chiaro di Luna.
Okay, well. I'm not familiar, but that's a good excuse for me to become
The Moonlight song is from Beethoven is a sonata, and is divided in 3 parts.
Yeah.
The first one is very quiet. The second one is a kind of warm up. The third one is a fantastic piece. I play piano. I played piano for 9 years, classical music, and I've never been able to make the third part because you have to be a pro to play that, and it just listen to that if you've never done. Super fast, super energetic. It's great.
Oh, fantastic. That's great insight. Thank you.